Tinder, beer, and Guess Who are all fun and games, but recommendation systems are also a very serious business. They have close conceptual ties to the core of a democratic society, such as how to run elections or elect governments based on collective opinions. This is called social choice theory. How does it work? We have discussed enough example of what a recommendation system is and its utility. Now the question is, how do we do it? How do we go about building it? Are Tinder, Pandora, and the Amazon recommendation system built on the same principles?
Well, recommendation systems are age-old. The way they have worked historically is by we calling up our friends, people we know, and whose opinions and preferences we trust, and ask them for suggestions. At the core, modern recommendation systems are not much different from this. They are automated, they operate at scale, and hence require some sophistication. Very crudely speaking, to find what you might like, we can find other people with similar tastes, similar interests, similar preference, similar opinions, and then use their preferences to dislike what I might like or I might dislike. Such algorithms are known as collaborative filtering. We filter or predict preferences through collaboration. We shall spend quite a bit of time in this module discussing various algorithms for recommendation based on this very basic insight. This insight, when viewed mathematically, leads to unusual algebraic approaches for recommendation. It might be worth cautioning that while the insight described seems very simple, it takes a lot more to actually building a real system, and we shall discuss all of this as a part of this module. So before we go into details, let's discuss a few of the nuances involved in building a recommendation system.
Transparency of recommendation systems are important. When systems like Amazon product recommendation chooses to display an item, it is important for the user to understand what that means. For example, it is important to tell them that this is the item that they may want to buy together with another item. If you're buying an electric snowblower, make sure that you get a long extension cord, as you will need that. When a recommendation for such an extension cord is made, it is important that the user understand why this item is recommended. In this case, that the cord was frequently bought together with the snowblower. Similarly, when you are recommended a movie like Goodfellas, you may want to know that you are suggested it because you watched and liked The Godfather, not because you watched SpongeBob with your 3-year-old.
Simple machine learning doesn't work well for recommendations. Remember Pandora, the music streaming company we spoke about earlier? It works like this. You create a virtual station on Pandora by suggesting the name of a band or a song or whatever, and then Pandora keeps streaming music that corresponds to that station's flavor. Initially, when Pandora started, they were trying to build such a system without really using recommendation system data. They didn't have any to begin with. Instead, they hired specialists that annotated songs based on musical characteristics such as electric guitar riffs or minor key tonality and whatnot. And they ended up building a very good system that thought that Bee Gees was like Beatles. Not sure if Bee Gees fan, or for that matter Beatles fan, would agree with that. Looking under the hood, they realized that the reason behind such a mess was very simple. In early part of their career, the Bee Gees were aspiring to become like Beatles. Effectively, they were a Beatles knockoff.
Now, of course, if we looked at the people who listened to those popular Bee Gees songs, they would be very different from those who listened to the Beatles. And this suggests that the importance of behavioral data in building recommendation systems. It's truly social. To know your preferences, you don't really need to understand why you listen to the Beatles, but find out who also likes the Beatles and see what else they like.
But behavior data is not easy to get. Think of Netflix on day one.
Or Pandora on day one, for that matter.
When you do not have any behavioral data, it makes it really hard to get going, or you do really poorly in the beginning. This is known as the cold start problem. There are many ways to get around this, and we shall discuss this aspect later in the module. Now, as we know, Pandora has gone on to become a very successful recommendation system. So they really did solve the cold start problem.
Self-fulfilling prophecy. A major flip side of recommendations is that it may not allow for discovering new things by chance. Effectively, a good recommendation system will keep recommending things that are liked or preferred by most and create a herding phenomenon. Newcomers who are really good might not get enough attention at all. This is a typical self-fulfilling prophecy phenomenon. We will discuss how to avoid this in a principled manner in this module.
Recommendations are means to an end. Looking for a suitable person to date or marry when you do not know exactly what you're looking for, or a new restaurant to eat, movies to watch, songs to listen to, or
There are businesses opportunities, targeted advertising, product purchase, suggestions, and whatnot.
recommendations should be objective driven. Advertising to increase click-through rate, product recommendation to increase conversions. Recommendations for profit increase might be very different from the recommendations that you provide for customer satisfaction.
Building a real system is a lot more complicated. Building a real recommendation system requires a lot of context-specific system design in addition to all the basic principles that we will learn in this module. So if you have to build a recommendation system that works for you, this module will provide you with all the essential knowledge that you need in addition to all the knowledge that you have from your domain, context, or application. When put these two together, you will have a functional, high-performing recommendation system.